There we go. Okay, so we have covered up through library of functions. That's what the last test was about. So we're pretty much done with all that. We had also done graphing techniques and completing of the square, but that was not on the test. So we talked about, well, a little bit, the graphing techniques, a little bit of it was there, but the completing of the square, that part we did do is the last class before the test. So I know it's been a while. We're going to continue with that. And today we're going to get into quadratic functions and their graphs. And I'm also going to try and talk about quadratic inequalities, but the fact that I've eaten up half the class, I'm pretty sure I'm not going to be able to do that. So let's at least try and get through quadratic functions today. That was to remind me. Okay, so quadratic functions. Up to this point, we should all be comfortable. You know what? Let me give you a big picture of what we're doing. Okay, big picture. There are 6 types of functions that college algebra students need to know in order to move into the next class. These are things that you should be very familiar with. The first type of function that everyone should know is a linear function. Well, that's just a line, and a linear function looks like this: f of x equals mx plus b. A specific example of that would be something like f of x equals negative 4x plus 7, let's say. And if I asked you to graph this, everyone here should be comfortable doing that. You know what the slope is, right? You know the slope of this line. This is the slope. This is the y-intercept. And so you should be comfortable graphing a line. The next type of function that we need to be comfortable with is a quadratic function. Okay, an example of a quadratic function would be, or the general form is f of x equals ax squared plus bx plus c. And I could give you a specific example, but we're going to do that all day today. Okay, so that's the second type of function college algebra students need to be comfortable with. That means you need to be able to graph a quadratic function. You need to understand the characteristics of a quadratic function. The third thing we have to study in this class are what are called polynomial functions. I'll give you examples of those when we get to them, okay? Functions. The next thing is called a rational function. Rational function. The fifth one is an exponential function. And the last one is a logarithmic function. Okay, those are the 6 basic functions that everyone finishing college algebra should feel comfortable with. And each one of these requires a different sort of approach, right? If you're going to be trying to look at, what are the characteristics of a quadratic, it's going to be completely different than what you do when you look at a polynomial, and it's going to be completely different than what you do when you look at a rational. Every one of these is uniquely different. And the reason why we study different functions is because the real world, certain things behave certain ways. Some things are linear, like, just go like in a straight line. Some things are quadratic, some things are polynomial, some things are rational, some things are exponential, some things are logarithmic. And so we need to understand these. The hardest of all of these, in my opinion, is rational. These are very complicated, all right? There's a lot going on here, but we'll get to that later. So today we want to focus on, quadratic functions. And the whole goal here is this. The goal is I give you a quadratic, you sketch it. All right, that's the goal. Now, within that, there's going to be a lot of little things you learn, but that's the main idea. I present you with the quadratic function, and then you be able to produce the graph of that for me. All right. So let's get into it. So quadratic functions let me define what they are. Quadratic functions are any functions that look like this: ax squared plus bx plus c. Here, when I write it this way, a, b, and c are just numbers. And we have one more condition: a can't be 0. And the reason a can't be 0 is because if a was 0, right, then it would completely kill this off. And then you wouldn't have a quadratic anymore because you wouldn't have an x squared term. So that's what makes quadratic quadratic, is the fact that your variable in there is squared. So that's why we have to have that condition that a can't be 0. You can have the b be 0 and the c be 0. One of them or both of them, it doesn't matter. But you just can't have the a be 0. So let me give you some examples of quadratic functions. Examples. So here's the first one: f of x equals, let's go with something basic first. Okay, that's an example of a quadratic function. Let me give you another one. X squared minus 4x. That would be quadratic. X squared minus 5 would be quadratic. Just x squared would be quadratic. As long as you've got your variable squared, you've got a quadratic function. Now, on the first one, who wants to tell me what a, b, and c are?
A is 1.
A is 1. That's the number in front of x squared, right? B is
right. -4.
-4, and c is
-5.
-5, right? Everyone got that? You're just picking off the numbers that are in front of the x squared, the x, and then the number by itself. That's a, b, and c. Okay, on the next one, the number in front of x squared is 1, so a is 1. The b here is the number in front of x, which is -4. And what about c? What's c on the second one?
0.
0, because there is no c, right? There is no number there. So you have to imagine that there's really like a plus nothing there. On the next one, the number in front of x squared is 1. A is 1. B here is what? So b is the number in front of x, right?
0.
We don't have an x, right? There's no x term here. So b would be 0. And then c here would be -5. And on the last one, a is 1. That's the number in front of x squared. And then we don't have an x term and we don't have a constant by itself. So both b and c would both be 0. So that's what quadratic functions look like when they're presented to you as functions, right? Our goal is going to be to graph these. Before I get into graphing them, though, let me see. I'm going to go back. I want to remind you, where was it? Remember last time we talked about, it's been a while. Let's see here. We talked about linear equations, quadratic equations. And I told you when we're solving a quadratic equation, we can do this thing called completing the square. Does this look familiar? Completing the square. We went through how to complete the square. And then after that, after we did an example, we talked about another way to solve a quadratic equation, and that was to use a quadratic formula, right? Remember that? And I actually told you, you can get, I think we derived it, didn't we? Did we derive the quadratic formula? No. I said we could get the quadratic formula from completing the square. Yeah, here, I derived it. Yes, I did. I knew I did. And then I told you there's no formula for cubic, and that's kind of where we ended things. But we had talked about parabolas, quadratic functions, right? And we had talked about when you graph them, you get a parabola that opens up or down. That's what they look like. Does it look familiar? In that, when you look at the x-intercepts, for any parabola, you're either going to have 0 x-intercepts if the parabola doesn't touch the x-axis. You're going to have 1 if it just touches the x-axis, or you're going to have 2 if the parabola hits the x-axis twice. And that's kind of where I talked a little bit about where you see parabolas, right? In flashlights and satellites and things like that. So with that information, let's talk about the general characteristics, the graph of any quadratic function. Will be one of these. Okay, so there's 2 scenarios here when you graph a quadratic function. You're either going to have a graph that opens like this, up, or it's going to be a parabola that we say opens down. And there's an easy way to tell which of these 2 cases it is. All you have to do is look at A. That number in front of x squared will always determine upward or downward opening of the parabola. We get opens up if A is greater than 0, and we get down if it's less than 0. Okay, so that's the big thing. We will have a parabola opens up if the number in front of x squared is positive, and we will have a parabola that opens down if the number in front of x squared is negative. That's the first thing, okay, about graphs, is that it's one of those 2. The next thing that I want to talk about in terms of the graph of a quadratic function is this thing called the vertex. The vertex of a quadratic function. So let's say you graph a quadratic. It's either going to open up or down, right? It's either up or down. Let's just say for this demonstration, it opens up, right? So let's say we have this, okay? So we already know here A would be positive, right? This point at the bottom of this parabola is called the vertex. And in this particular case, isn't this the lowest point on the graph? That would be what we would refer to as a local minimum, right? Well, actually, this is the absolute minimum. It's the lowest point on the entire graph. That vertex is a point. And since it's a point, it has an X and a Y coordinate. And whenever we're talking about parabolas, we don't use X and Y to label the vertex. We use H and K. But H is just how far you move this way. H is your X coordinate of that point, and K is the Y coordinate of that point. Now, if your parabola opens the other way, right? If your parabola opens this way, then now your vertex is the absolute maximum or the highest point on the graph. But again, that vertex has coordinates HK. So here's H and here's K. So wouldn't it be nice if when somebody gave us a quadratic function, wouldn't it be nice if there was an easy way to determine what that point was? Right, just by looking, you know how when we look to see if it opens up or down, all we do is look at A, right? Positive, it opens up, negative opens down. Wouldn't it be nice if we could just look at this quadratic function and determine whether or not, determine what the vertex is, right? To determine exactly what it is. That'd be nice. Well, we do. We have a formula for finding the vertex for any parabola, for any quadratic function. And the formula is this. It's called the Vertex Formula. Here's what it says. If you want to know what H is, H, this first number in the ordered pair, right? The X coordinate of the vertex will always be negative B divided by 2A. So remember how we were up here identifying what A, B, and C were, right? We did that right here. We did A, B, and C. Well, if you know A, B, and C, A is going to tell you if it opens up or down. And then if you calculate negative b divided by 2a, that's going to tell you the x coordinate of the vertex. That's going to give you the x coordinate. And then if you want to know what k is, all you have to do is take your function and plug the answer you just got. So you're basically going to be taking that answer, right? This is h. And you're going to plug it into the function. And that will give you the k every time. I wonder where this formula comes from. It actually comes from calculus, okay? If you take calculus 1, then hopefully your professor will show you this, where that comes from. Hopefully they will, they should, but it's easy to show in Cal 1 that this is it. I'm actually getting real close to showing my class that in my Cal 1 class. I'm about to show them the vertex formula. Well, we're going to generate the vertex formula. So that's it. So now think about what we know. If somebody gives us a quadratic function, we can now determine if it opens up or down by just looking at A. We can actually figure out what the vertex is by using that formula. So now let's look at the next thing. We were talking about X-intercepts. And remember, we said last class that we can have 0, 1, or 2, right? All parabolas are going to have either 0, 1, or 2 X-intercepts. The question is, how do we find them, right? To find them, we do what we do for any function. When we try and find the X-intercepts for any function, we will set the function equal to 0. Always. And when you do this, you're going to get a quadratic equation. And the way we solve that is really kind of like one of 3 ways. To solve this, we're either going to, we're going to factor if we can. We can also complete the square. Although I don't recommend completing the square, because we learned after completing the square that we had the quadratic formula. So I would say 1 and 3 are your best options for figuring out the x-intercepts of a quadratic function. You're either going to factor it, so you look real quick, see if you can factor it. If you can't factor it, use a quadratic formula. Is everyone clear that we talked about this last time, that when you have x-intercepts of a parabola, we either have none, 1, or 2, right? It's not possible to have 3, right? Or 4 or 5. We can only have none, 1, or 2. What about y-intercepts? We never talked about y-intercepts last class, did we? Let's talk about them now. How about the y-intercepts? So I'm going to draw a couple of pictures and let's see if we can figure out what the y-intercepts would be. So let me draw one that opens up. I'm going to draw one that opens up and doesn't hit the x-axis. And I'm going to draw one that opens down. Let me draw it over here like this. And then let me draw one, I guess, I don't know, I'll just make it go like maybe over here like this. I'll do it over here. What do y'all think in terms of y-intercepts? If I give you a quadratic function, ask you to graph it, what do you think about y-intercepts? Javier's saying 1, right? 1 or none. What do you think? Miguel's saying 1. Look at the first picture. Is it obvious that I hit the y-axis 1 time? Right? So here we have 1 y-intercept. What about this one? Am I going to hit the y-axis? Well, my picture doesn't look like it is, but this continues down, doesn't it? And down and down and down. And eventually, wouldn't it hit the y-axis somewhere down there? So when you draw a parabola, it looks like a U, but look, not a U like this. It's not a U where the sides go straight up, right? Whenever you have a parabola, you always have kind of a flaring out of the U. It always has to continue in both directions forever. So even though I drew this where it doesn't look like it's hitting the Y, eventually it will hit it down here one time. And same with this one over here. Eventually, way up there somewhere, it's going to hit. So I'm going to have 1 here. So for all quadratic functions, you will have 1 y-intercept, and that's it. You can't have none. You cannot have none. You have to have 1, and you can't have 2. Because think about it. If let's just say your parabola hit more than one place on the y-axis. Let's say it hit twice. Wouldn't it fail the vertical line test then? And it would, if it fails the vertical line test, then it would fail to be a function. So that can't happen. So for the y-intercept, I'm going to put here, we'll always have 1. And then to find it, it's very easy to find the y-intercept. To find it, we find f of 0. Think about what that means. You're plugging 0 in for x, right? You're saying, hey, what happens when I plug 0 in? And then whatever the function spits out is where the point is on the y-axis. So this is like your x-coordinate, right? And if your x-coordinate is 0, you're on the y-axis. Okay. All right, so that's it. This is really the framework of what we need to sketch a quadratic function. We need to know if it opens up or down. We need to be able to figure out the vertex. We need to be able to figure out the x-intercepts, if we have any. We need to be able to figure out the y-intercept. And then from that, we should be able to draw a picture. All right, so let me formally write down the steps for sketching a quadratic. How to sketch a quadratic function. All right, first step. Does it open up or does it open down? Okay, that's what you're going to do first. You're going to figure out if it opens up or down. And to do that, all you're going to do is look at A, right? You're going to look at A to do this. Simple enough. Step 2, you're going to find the vertex. You're going to find you find vertex HK. And to do that, you use the formula. That is, H is equal to negative B over 2A, and K is equal to F of H. The third step in this is something that I do that not a lot of books do, not a lot of tutors or other professors will do this, okay? But I like to do this third step. I do a quick sketch. I do a quick sketch. And you'll see when I actually do an example what I mean by this. But what's going to happen here is this is going to allow us, this allows us to determine the number of x-intercepts. So remember, when it comes to x-intercepts, we can have none, 1, or 2. If we do a quick sketch, that will help us determine how many we have. And you'll see when I do an example. Fourth step, find the x-intercepts if you have them. If you have any, I'll say. And we know to do that, we set the function equal to 0. And then it's either factor or quadratic formula. Fifth step, find the y-intercept. We guarantee have one. So all we're going to do here is plug 0 into the function. And the final step is to sketch it. See, so like if I provide you the opportunity to have a reference sheet, right, for the next test, I would put this on there, right? I would put this on there. So it's weird because the math department, every math department I've ever taught in different schools, I've only really taught at 3 different schools, but everyone has different opinions on whether or not you should let students have formulas and things on tests. There's kind of different mentalities on it, different opinions. My opinion is that you should be able to use a reference, only because in the real world, right? Like let's say become an engineer and you're working on a problem, very seldom are you actually like trapped in a room with no resources. You usually have something that you can refer to. It's, can you use it properly, right? Like, do you know what to turn to? Do you know how to utilize that tool, that resource? So that's what I want the reference sheet to be for you, is something that you've created that you know will help you. All right, you ready to do one? I'm going to copy this. We're going to take this to a new page and we're going to try and graph ourselves a quadratic function. And we're going to start with a baby one. Baby meaning none of the work is going to be too hard. Okay. So I want us to sketch f of x equals, let's go with that first one we had, x squared minus 4x minus 5. Okay. I want you to do steps 1 and 2 on your own right now. I'm going to just go refill my drink. I think I talked too much. It was too much passion in my talking earlier. My throat hurts. So I'm going to let you figure out if it opens up or down. And then I want you to use these formulas to see if you can figure out the vertex. And I'll be right back. And I'm going to send a poll out. Just let me know if you do get the first 2. Just let me know when you're done. I'm going to just start working these out silently, and you can just take a look and see if you're getting the same thing. Okay, I just finished it. I've still got some people that haven't finished, but I'll let you look at that for another 10 seconds and we'll talk about it. Okay, does anyone have any questions? Do y'all see that in the very beginning? I wrote A, B, and C down. I always recommend you do that. In fact, if you want, you could add a step 0 to this, okay? And just tell yourself, go find A, B, and C. That way you have it for the rest of the problem if you need it. So A is 1, that means it's positive, we open up. To find H, I took negative B. Now you have to be careful because B was -4. So you have to do negative -4, which turns it into a +4. And then 2 times A, that's 2 times 1, which is just 2. That gives you 2. So then you take that answer and you plug it into the function, which just means you take 2 and you go to your original function up here and you replace the X here with 2 and 2. That's what I did here on this line. And then I got -9. And then I write it as a point, okay? I write it as a point. 2, -9, that's a point. That's going to be I put it's the absolute minimum because the parabola opens up. It would be the lowest point on the parabola. Is this all okay? Next step, the quick sketch. And I said that the quick sketch is going to allow us to determine how many X-intercepts we have. So when I say quick sketch, I mean quick. All right, watch how I do this. I know I have a vertex, right, of 2, -9. If I asked you to plot this point, you would go to the right 2 and down 9, right? That's what you would do. I'm not even going to count. I'm just going to say I go to the right and I go down. So my vertex is somewhere down there, right? I don't even care where it is, just it's down there. Now the parabola opens up, doesn't it? And that's the lowest point. So if it opens up and that's the lowest point, then it has to hit the x-axis twice, right? Which means I know now it has 2 x-intercepts. Which means I should do step 4, right? Because step 4 says find the x-intercepts if you have any. And I do have them. So now I'm going to move to step 4. Questions on that quick sketch? Okay. All right, so I'm going to set the function equal to 0. So I go to the original function x squared minus 4x minus 5 equals 0. Okay, so now I have choices, right? Because this right here is a quadratic equation. Quadratic equation. And I'm going to factor this because it does factor. This factors to be x minus 5 times x plus 1. And then if I set each of those equal to 0, I get 2 solutions, positive 5 and negative 1. Now, if this is me factoring, right? This is me doing the factoring approach. If I were to instead use the quadratic formula, then I would have to go back last class and use this formula. X is negative b plus or minus the square root b squared minus 4ac all over 2a. Now, I'm not going to show this work. I'm just going to write it down what it would be here, what you would plug in. You'd have negative b, which would be positive 4, plus or minus the square root. And then you'd square b. B is negative 4, so when you square it, you get 16. Minus 4 times a, which was 1, and c, which was negative 5. Oops, negative 5. Then all over 2 times a. And what I'm telling you is that if you do this, you'll get 2 answers. One of them will be 5, and the other one will be negative 1. So I'm not showing that work. We'll do a problem if I have time later where we have to use that quadratic formula. I'll go through a little more detail on it. But I'm again trying to reiterate that we're either going to factor or we're going to use a quadratic formula to do that. Okay, so I've got my two x-intercepts. They're at 5 and at -1. The fifth step is the y-intercept. And for that, I just plug 0 into the function, which means I do 0 squared minus 4 times 0 minus 5. Can anyone tell me what the y-intercept will always be if our parabola looks like ax squared plus bx plus c?
Would it be C?
It'll always be c, exactly. Because these first two pieces are always going to go away. So you're just going to get what c is, -5. Questions? All right, let's go. Let's do it. I'm gonna
Actually,
skip-
if we were to put that as an answer, would you want us to put just -5 or would you put -5, 0?
Okay, good question. So I was gonna mention this. I decided not to because I said, okay, if it's an x-intercept, you know that these are points on the x-axis. Y-intercept, you know this is points on the a point on the y-axis. But if you wanted to, you could convert this to a point 0, -5. That's a y-intercept because the x coordinate 0. And then these two you could convert to 5, 0 and -1, 0. And then you're looking at them as points. I don't care what you do. You can leave them as x equals 5, x equals -1, and just write -5 here. It's fine with me. Or you can write them as points. All right, I'm ready to put this all together. I'm ready to draw a picture. Okay. So this is my last step. I'm gonna do it on a different page. Here we go. Now look, this graph needs to be decent, but we're not trying to land a man on the moon here, okay? It doesn't have to be that precise, but you want it to be somewhat accurate. So what I like to do is I like to think about what I have. I know the vertex is 2, -9. I know my x-intercepts are at 5, 0 and -1, 0. I know my y-intercept is at the point 0, -5, right? That's kind of what I know. So the reason I look at this way is I'm trying to figure out how far left and right my scale needs to go and how far up and down. So look at the vertex. The lowest point I'm going to go is -9, right? And if you look at the x values, 2, 5, and -1, I only need to be able to go left and right at least 5 units. So that kind of helps you draw your scale. So here's the way I'm going to do it. I'm going to say this is 1, 2, 3, 4, 5, 6. Of course, this would be -1, -2. And then in terms of up and down, I'm going to count by ones here. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10. And then the other way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10. What I'm trying to illustrate here with the way I drew this is when you draw a graph, your left and right distance, if I say that's 1, does not have to be the same on the up and down distance. Okay, so 1 unit left and right does not have to be equivalent to 1 unit up and down. You can change the scale because this is 1 unit, that's 2. What you can't do is change it on the x, like you can't call this 1 and then on the other side make this -1. You have to keep the scale consistent within each axis. Questions there? I'm going to draw it now. Here we go. It's going to be in red. I'm going to start with the vertex, 2, 9. Go to the right, 2, down 9. I'm going to label the point, 2, -9. I said 2, 9, 2, -9 is what I meant to say. My x-intercept is at 5, 0. That's here. My other x-intercept is at -1, 0. And my y-intercept is at 0, -5. Right there. And now I need to draw a U-shape parabola through those points. Now there's an imaginary line, it's not part of our graph. There's an imaginary line that goes through the center of the parabola. This thing has a name. It's called the Axis of Symmetry. And all this is a reference for you to use, that your parabola should look like a mirror image of itself over that line, like a reflection. So when I look to draw this, I noticed that on the left side of this axis of symmetry, I notice I have 2 points, but on the right side, I only have 1. So I'm going to use the left side to draw. I'm going to draw the left side first because I have more information over there. And when I draw it, I'm going to draw a U-shaped thing like this and continue it on and put an arrow on it. And then I'm going to do my best to draw a complete like mirror image of that on the other side. Like I don't want to do this, right? That doesn't look right. I don't want to do this. That doesn't look right, right? It needs to look like a mirror image. So you do your best, something like this. And that's it. Once we have this, now we can answer a bunch of questions, right? Like what's the domain? What's the range? We could talk about where is it increasing? Where is it decreasing? We can talk about what's its local max, local min, absolute max, absolute min, all those things that we've done before on the table here. But we have a graph of the function. Okay, I have time for another one. Here we go. Questions? All right, how about this one? Let's sketch. I'm going to make this one have something interesting happen. F of x equals, let's go negative x squared what do I want to do here? Minus 2x minus 1. I'm going to go back here. I'm going to grab those steps so we have them. All right, first step, I'm gonna do step 0. Okay, I'm gonna go ahead and do A is -1, B is -2, and C is -1. Just list out the A, B, C first. Then I know it opens down. It opens down because A is -1, right, which is a negative number. The next step is the vertex. So I have to get H. H is negative B over 2A. So -2 over 2 times A, but A was -1. So be careful there with all those negative signs. I should give you 2 over -2, which is -1. Any questions there? Why don't you try K? This is, students always mess K up with things like this. You try and get K. I'm going to give you like 40 seconds to get K. Okay, I think that's been 40 seconds. All right, so who wants, should I call on somebody? I should call on somebody. Let's see who I haven't called on in a while. Monica?
Hi.
Hi, did you get K?
Yes. 0.
0? Anybody disagree? Good, that is correct. So let me just show the calculation. It was negative, and then you had to do -1 squared, then -2 times -1, then -1. That is a lot of negatives to keep track of. So this x squared, very important that you put the -1 in parentheses and then square it. Now look, you square before you do the double negative. So I have to square this first. -1 times -1 is +1. And then it becomes -1. And then now when these two multiply together, you get +2, and then you still have -1. And that's going to give you 0. -1 + 2 - 1. Very good. That's our vertex, -1, 0. Next step. What's next step? Quick sketch, right? So when I do my quick sketch, I go to my vertex, which means I just move to the left 1, right? That's it. I don't go up or down. I just move to the left 1, and that's where my vertex is. And then I need to draw a parabola that opens which way? Down. Good, Javier. Down, right? So can you tell me how many x-intercepts I have? 1. Good. I see 1 x-intercept, right? Do you know what it is? Yeah, it's the vertex, right? It is the actual vertex, is the x-intercept. It's the only one you have. So for step 4, I have 1 x-intercept, but it happens to just be the vertex because the vertex is the only point that touches the x-axis, which is going to be the point -1, 0. That makes sense, everyone? 5, y-intercept. It's just C, isn't it? So I'll write it as a point. It's 0, -1, right? That's just C. And so that should be everything I need to draw this. Let's try it. I'm going to just squeeze it in right here. I don't have a ton of information, do I? I have a vertex of -1, 0. And the only other thing I have is a y-intercept of 0, -1. And that's all I have to draw this thing. So I kind of imagine a axis of symmetry here. I need to draw a parabola that goes down. So I'm just going to do my best here, like this. That's not very good. That's okay, I guess, right? I just try and draw a mirror image of itself. See, this problem was interesting because your vertex was your x-intercept. So you only had 1 x-intercept. So we never had to factor or use a quadratic formula, right? The downside is we only had 1 point, right? We only had actually 1 point to work with here. Okay, I have 10 minutes, right? So I have time for one more. This one will be harder. Ready? I've kept the numbers nice. I've played nice. No more playing nice. You've got the basic idea now. So let's sketch this one. F of x equals -3x squared plus 7x plus 12. Things are going to get pretty crappy pretty fast. So step 0, I guess, is we identify A, B, and C. This thing is going to open down because A is a negative number. So it's less than 0. And here's where things start to suck, my vertex. I'm going to use that formula, right? Negative B over 2A to get my vertex. Isn't that going to be in a fraction, right? That's going to suck. It's going to be negative 7 over 2 times negative 3. That's negative 7 over negative 6. And that's going to be positive 7 over 6, right? This is the first time we've had something like that. Up to this point, there have been nice numbers. This is not a nice number. So we have options. We could leave it as a fraction, okay? But then we have to plug it into the function as a fraction, don't we? Or we can get it as a decimal and then use that decimal and plug that decimal into the function. It's your choice, but we're eventually going to have to plot this point. So getting a decimal is probably better. So I'm going to go 7 divided by 6 on my calculator. This is approximately 1.1666, and it keeps going. Why don't we round that? What do you say we round this to say approximately let's go 1.17. How about that? We'll round it 2 decimal places. That seem fair? Remember, you're going to have to plot this point, right? You can only be so accurate with your plot. So if we round 2 decimal places, you know, we're going to get as precise as we can with our pencil. Now I get K. So for K, I'm going to take negative 3, and then I'm going to take the answer I just got, 1.17 squared plus 7 times 1.17, then plus 12. So I'm going to need to be doing some calculator work here. First thing I do is square the 1.17. So this becomes negative 3 times 1.3689 plus, if I do 7 times 1.17, I get 8.19 and then plus 12. So essentially what I did here is I squared that, and that's what this is. And then I multiply these two together, right, to get that. I still need to multiply negative 3 through times that thing right there. So I'm going to take that answer, multiply by negative 3. I get negative 4.1067 plus 8.19 plus 12. So now I'm just going to do that all on my calculator. Are there any questions on what I'm doing here? .08 is what I get. 16.08. So I have my vertex 1.17, 16.08. Yeah, and that sucks. All right, they're decimals. Third step, quick sketch. Okay, 1.17 means move to the right a little bit, and then 16.08 means move up. So I know my vertex is somewhere to the right and up, and my parabola opens down, which means I'm guaranteed to have 2 X-intercepts. And right there, right at that point, I know that I'm going to wind up either factoring or using quadratic formula, because I'm going to have to set the function equal to 0 to figure those out. So for step 4, I take the original function, negative 3, I'm finding the X-intercepts, negative 3x squared plus 7x plus 12, and I'm setting it equal to 0. And I do not believe that factors. I didn't think about it too much, but I intentionally was trying to make it not factor. 2 numbers that multiply to be 36 and add to be 7. I don't think that that's going to happen. So quadratic formula. quadratic formula. X equals negative b plus or minus square root, all that stuff. I'm not going to write the formula down again. I'm just going to go straight to this. Negative b plus or minus the square root of b squared is 7 squared, that's 49, minus 4 times a, which was negative 3, times c, which was 12, all of it divided by 2 times a. Now, when I use the quadratic formula, what I like to do at this step is I like to count underneath this root. I write the 49, and then I like to count how many negatives I see. I see 2 negatives. If I see 2 negatives, then I know 2 negatives becomes positive. If I saw 3 negatives, then I would say, oh, 3 negatives would stay negative, right? Negative, negative, negative would be negative still. So if I see an even number of negatives, I'm going to make a plus sign. If I see an odd number of negatives, I'm going to put a minus sign. Since I see 2 negatives, I'm now going to put plus here. And then I just take these numbers. I don't even care about their signs. I multiply those numbers together. So I do 4 times 3 times 12. That would be 144. And then I divide the whole thing by negative 6. Then continue. Okay, I take 144 and I add 49, right? And I get square root of 193 over negative 6. And now I have to take square root of negative 193 on my calculator. And when I do that, I get 13.8924. So I'm just, again, going to round this. I get 13.8, I'm going to say 89 all over negative 6. So just keep in mind that at this stage, I actually took that square root, right? I took the square root, so I no longer have the square root symbol. It's just the 13.89. And then here, this gives me 2 different answers. So the first answer is negative 7 plus the 13.89. Then divide by negative 6. The other one is negative 7 minus the 13.89, and then divide by negative 6. I'm starting to run out of time. So I'm just going to tell you what the top one is. The top one should be 1.15. And then the bottom one, hold on, I think I messed that up. That was supposed to be a minus, oops. Minus 1.15 up here. And then this bottom one should be a positive 3.48. 1 minute, 1 minute. Can I keep moving? Step 5, Y-intercept. That'll be C, right? Wasn't it 12? I'm just going to put 12 here because I want to get to the graph. I think right here I have everything I need on screen. I'll try and squeeze this in here. Okay, my vertex, I need to go to the right 1, go up 16. Look at my x-intercepts. They go between -1 and 3. And my y-intercept goes all the way up to 12. So here's the way I'm going to do this. I'm going to count 1, 2, 3, 4. That should take care of my x-intercept. And since I've got to go all the way up to 16, I'm going to count by 5s. 5, 10, 15, 20, and then -5, and so on and so forth. Starting with the vertex, I need to go to the right 1.17 and go up a little bit more than 16. So this is, again, where you have to kind of eyeball this to a little bit to the right of 1, a little bit above 16 or 15, 16, sorry. And that's why it's important to label the point. That way I can tell when I look at it exactly what you meant. Okay, to the right 1 point something, up 16 point something. I have an x-intercept of negative 1.15, so somewhere around here. And then 3.48 is almost 3.5, so somewhere around here. And lastly, I have a y-intercept of 12, which is somewhere around there. And it opens down, remember? It opens down. So I have this like axis of symmetry through here. Oops, yeah, through there. And so I'm going to do my best here. It does something like this. That point is the point 012. Okay, we're out of time. On your homework, okay, on your homework, let me see. I don't think I have it up anymore. See how you do on your homework for this section only. This section is 4.3. Homework 4.3 and homework 4.5 aren't due until the 27th, right? Which is, oh, well, that's our next, yeah. So only work on the 4.3 homework. Okay, only the 4.3, and do the best you can. The first problems, they ask you to match a graph to the function. See how that goes. The problems at the end are more like this, where they ask you, they give you the function, they ask you to just do all these steps and then graph it. All right, see how it goes. We'll do more of these when we get back next week. We'll continue with these, and we'll do the quadratic inequalities, and then we'll move into polynomial functions. Quadratic inequalities should only take us like maybe 20 minutes. So don't worry about the 4.5 homework. I will extend the deadline for that. The 4.5, all right? Everyone have a good weekend.
You too, Professor.
All right. Reach out to me if you need to talk about
Thank you,
anything, grades or anything else. Just
Thank
reach
you.
out. Have a good one.
So only do 4.3?